Hey, my lovely students. You all are beautiful, beautiful students, and I'm so glad you're here with me to learn about how we can apply our properties of perpendicular bisectors within a triangle. It's going to be great. Get excited. Okay, so it says that G to the E, so GE, GF, and GD are perpendicular bisectors, which what does it mean again to be perpendicular? I knew you guys would know it. It does mean to hit a side at a 90-degree angle. So if you notice, all three of these do hit the sides at a right angle, okay, which technically these lines should keep extending, the green ones, but the reason why we didn't is because there's these other three segments in the triangle, which it's going to get a little confusing if we have these three lines extending and three more. So we kind of chopped off the lines once they hit that nifty point in the center, the point of concurrency, which, what is the point of concurrency called for perpendicular bisectors? It is a circumcenter. So this point in the middle is called the circumcenter. That bad boy right there is the circumcenter. If I can fit it on the paper. There we go. So don't forget, where all three of these perpendicular bisectors intersect, is at the circumcenter. So yay. But anyway, so these three segments are perpendicular bisectors. So not only are they perpendicular, they also bisect the side of a triangle. What does it mean to bisect? You are correct, Amundo. It does hit the side and slice it in half. It's quite violent. It slices it in half, which means it creates congruent segments, which I'm going to label those parts of my triangle just in case it will be helpful when we're solving. So these two sides are congruent, these two segments are congruent, and these two segments are congruent. All right, and this right here, the perpendicular segments will also, perpendicular bisector segments, will be applied to our next example as well. So wait for that, it'll be exciting. Alrighty, so it says B to the C is 16. So BC, this whole side of my triangle, is 16. Cool beans. Okay, it says AG is 9. So A to the G is 9. So this side is 9. Bam. All right, and then GF is 4. So GF is 4. All right, and it also tells me B to the G is 3x plus 6. So BG is right here. That bad boy is 3x plus 6. Okay, so in this problem it says not only are we solving for x, we're also going to find CG. So get excited. It'll be a blast. Wait for you guys. Okay, so I need to dissect what I have in my picture right now and see what is helpful and what is not. Because ultimately I want to find x. And then after that, I also want to find CG. All right, now let's think back to that perpendicular bisector circumcenter theorem. Let's think back to it. So we learned about the circumcenter theorem, or the way I like to say it, circumcenter theorem. The circumcenter theorem says the circumcenter of a triangle is equidistant, which is the fancy way of saying the same distance from the vertices of a triangle. So right here is my circumcenter because here are my three perpendicular bisectors. If we draw segments to the vertex of the triangle from the circumcenter, they will be equidistant, which again is the fancy way of saying congruent, or the same distance. So these three segments will be congruent. So let's see if this will be helpful when we're solving. So let's go back to that lovely picture. So I'm also going to label those pieces as being congruent because maybe that will help me. I don't know. So let's see here. These segments right here are also congruent. Nifty, right? All right, well, there's a lot to dissect. Ultimately, we want to find x, okay, which this right here has an x in it, which that's one of the segments that starts from the circumcenter and ends up at the vertex. Okay, and then we want to find CG, which is another segment that starts at the circumcenter and ends at a vertex. Okay, so is there another value that we have in the triangle that might help me to find BG, which will help me find x, and CG? It will be AG. So AG is congruent to BG, which is congruent to GC. So that will ultimately help me find X and CG. All right, so I'm going to write that at the top so I don't forget. So I know that BG, the length of BG is equal to the length of AG, which is equal to the length of GC. And all that will help me find everything in the problem that I need to solve. All right, let's get started. Well, technically, I already know what CG is. Okay, technically, if these three are congruent, what would CG be? Which one of these is going to help me? AG is the one that's going to help me. You guys are brilliant. Okay, so if AG is 9, that means that CG is equal to it in length, which means CG will equal 9 in length. So CG equals 9. Bam. CG is donezo. Bam. Okay, so now I need to solve for X. So what could I use to help me find X? Well, I know that BG is equal to the length of AG, and I have a value for AG, so that will help me to solve for X. So I'm going to use these two pieces of this lovely setup to help me solve. So BG equals AG. All right, guys, let's solve for X right now. It's going to be fabulous. Okay, so B to the G is 3X plus 6. I'm going to fill that in. So we have 3X plus 6 equals AG, which AG is 9. All right, let's solve this bad boy for X. So I need to get X by itself. I don't have another X to combine to, so this is going to make my life infinitely easier. All right, so I need to move that 6 to the other side. That 6 is irking me. How do I move a positive 6 to the other side of my equal sign? I do subtract 6. You guys are mathematicians practically. You should just get a degree in mathematics. You're on the right track. All right, so 6 minus 6 cancels and turns to 0. What is 9 minus 6? It is 3. So we have 3x equals 3. All right, guys, we're so close. We're so close. How do I get my 3 by itself? Well, 3 is secretly multiplying to x, which means the opposite of multiplication is in fact division. So I'm going to divide both sides by 3, which 3 divided by 3 cancels and turns to 1. So we're left with x equals... Now 3 divided by 3 also technically cancels and turns to 1, but instead of canceling out, which might confuse some people and they might think it disappears, it does not disappear. 3 divided by 3 is 1. Technically there's secretly a 1x right here, but I'm not going to write the 1 on this one because I'm trying to find x, so I don't really need the 1 in front of the x, but x will ultimately equal 1. So I'm going to write 1 right here, and I'm actually going to keep it the same color because I want it to be color-coded. So x equals 1. Yay! Okay, so I found x and I found CG. Now, just to make sure that I did this right, it's always good to check your work. I'm going to solve for BG to make sure it equals CG, because if it doesn't, first of all, I might need to reevaluate the problem and possibly my life. I'm not sure yet. But anyways, if I find BG and it's wrong, if I substitute 1 in, that means I made an error here and I need to fix it. Okay, and the important thing in mathematics is finding a mistake. So let's see if I made a mistake, which I might have. The demon cats might have got me, you guys. I don't know. They're pretty vicious. Okay, so I'm going to quickly, over here, I'm going to squeeze it in. I'm going to substitute 1 in for x right here for BG, and let's see if we get 9. I don't know. I'm hoping. So we know that BG equals 3x plus 6. All right, and now that I know x is 1, what can I do with that 1 to find BG? You guys knew it. So you do replace x with the 1. Okay, so it's going to be BG equals 3 times my x will transform into a 1. So 3 times 1 plus 6. All right, let's do this thing. 3 times 1, that is 3. So BG equals 3 plus 6. And guess what, you guys? What's 3 plus 6? It is 9. So BG equals 9, which is good because CG equals 9. Yay! So x equals 1 is correct. Yay! We're super excited. We're having the ultimate excited party over here. That was awesome, you guys. Thanks for helping me solve this problem. I really need your help, and I'm thankful you're here to help me.